Hello, thank you, and welcome. We have a huge topic today, which is Rust error handling. First of all, my name is Martin, and this is my GitHub nickname, and this is also the nickname which I use on other social networks, except I don't use those social networks. We have many slides in front of us. I think it's 2 to the power of 6 minus 1. So let's get into it, because this error handling is pretty difficult. Or rather, maybe you have heard of it already. The Rust error handling is both awesome and very difficult. So why is that? Have you ever heard this? Like, some people say Rust error handling is so awesome, and other people say it's so hard. Have you ever encountered it? So why is that? We need to compare it to other languages to have perspective. So let's talk about C. So the error handling in C is totally messy, because some functions return 0 if they fail and 1 if they succeed. Some functions do it exactly the other way around. Some functions return -1 for error and 0 on success. And some functions return magic values for errors and some other values for non-errors. So it's really confusing, and you really don't know what the error type is unless you read a manual page of the set function, or that's if you are lucky enough. Of course, if you are unlucky enough, you have to read the body of the function itself. So that's the first problem, is that this big chaos. And there is also error number, which is a separate global variable. It's actually thread local these days, but it was a global one when it started. And the thing is that this error variable is set to the error code, like what exactly failed. So you could say okay, so let's just ignore all the other errors and just check the error. Unfortunately, I cannot do it, at least not practically, because the error is not reset when a function succeeds. So you would have to reset error every time before calling the function, which is both annoying and less performant. Then there is this question, let's say you open the file, and you get back error which says, let's say, file not found, and you print it out you return it from the function, then you return it from another function, and so on and so on. And then the function calls up, you print it out, and then, okay, but which file? You have no idea. You need to use strace. It's my magic weapon for finding these kinds of bugs in programs that I didn't wrote. That I just use strace on everything and find these things. But it's super annoying and something that normal user cannot do. Also, if you have code that has a lot of possible error cases, and maybe in most of them you want to just return from the function or print some error, you have your code littered with annoying ifs, and it's just 3 lines of code. Maybe if you have really short, you can do it in 1 line, but it's just 1 line for every possible function call that can fail. And you can possibly forget to check the return value. And the annoying thing about it is that in C, it can lead to undefined behavior, which is even more fun. Here's a funny story I saw in one production code. That once we were doing some cleanups, and we turned on the conversion warnings in the compiler. So we would get an error if there was implicit conversion from one variable type to another, which is another fun property of C. And I saw this warning, there is some function with, I think it was something like fwrite or something like that, some write function definitely. and it was returning some number, and it assigned it to it was size underscore t, so it was signed integer. But the warning was that the function actually returns unsigned integer. Okay, so I changed the variable type, obviously, and then it turned into another warning, one line over, that there was an if statement that was checking it against against 0, like if it's less than 0, so if it's -1. And the warning was obviously this is never true. So the entire error check was totally bogus, and it was impossible to see until I turned on these warnings. So that's a lot of fun in C. Let's talk about C++, then plus should be better, but unfortunately, if you are unlucky enough, you get all the garbage of C, because people often interface with C code, and they just include a header file and call the functions and so on. So you get everything that is in C, but plus more problems. One of them being that though the exceptions in C++ are zero cost of success, like there is no if statements in the generated code, or rather no like conditional branches, it gets super expensive when you do get an error. If an exception is thrown, the runtime has to somehow figure out like what the state of the stack is, and which things need to be dropped, and so on, or rather destructed in C++ terms, and then return from the function and so on. So it's okay for errors that don't happen often, but if you need an application that can react quickly even to errors, then you have a problem. Of course, then there is a question like, okay, I have a piece of code, and maybe it's some function, which are all possible exceptions that the function can throw. Hard to say. You have to read all the body of the function and the body of every function it calls, and of course recursively every body of the function it calls, and so on. So that's again really difficult, and you cannot easily tell. And of course, if you let's say forget to handle some kind of exception that you didn't think about, then your entire application crashes. Fun times. Of course, there is also the question like which of these functions can throw in the first place. Like if you for some reason need to know, like you have 5 function calls inside the function body, and then like, okay, I need to know which can throw, and again you cannot tell from just looking at it. So that's quite annoying. There is this new language called Go. Many people are very excited about it, but I don't see it that great in error handling space. So the convention in Go is that if a function can fail, you return a tuple. So it's 2 values. And the second value is error, which is nil if there was not error, and is non-nil if there was an error. And this value gets set to some object that implements some sort of error interface, which immediately implies that all errors need to be allocated on the heap, which is kind of not great for a very similar reason I mentioned in C++ case, which it may make error handling more slow, even if it doesn't have to be necessarily, because we are returning some trivial value, but you are now returning a heap allocated pointer, and you have the cost of heap allocation added to the cost of whatever else. So similar to C, it also requires you to do if statements all the time, which is again annoying and error prone. You could possibly forget to check the error, and you could possibly return nonsensical value from the function, such as both parts of the tuple being nil or both parts of the tuple being set to something. So the function failed and succeeded at the same time, or the function didn't fail or didn't succeed at the same time. So it seems to be some sort of a quantum language, I would say. And another annoying part about Go is that by default you can extract only a string from the function just directly, like you can get the message. And if you want to do something else, like check which kind of error it is, you have to do dynamic casting, which is possibly error prone because you have to write the correct possible type there. And if you make a mistake and accidentally try to match it on some type that the function doesn't throw, you never learn, and the code never hits. So basically, probably need to write a lot of tests to figure these things out. Then there are languages like Python, Java, and some similar other languages. And they share kind of similarities with C++, I would say. But it gets crazier because all exceptions are heap allocated. And again, same questions like what are the possible functions that can throw, what are the possible errors, just like in C++. And in some cases, you get a stack trace shown, or rather, user gets stack trace shown. And what does my mom think when she sees stack trace? Oh, of course, this is the problem, right? Probably not. So there is this thing, like they are maybe helpful for developers, but even if you are the developer, even if you yourself wrote the application, if you get your output covered with stack trace, it's kind of annoying. Maybe you wrote the application really nice that it should print nice error messages, but you still get the stack trace because you got an exception thrown. So that's kind of annoying. So let's stop talking about other languages and let's talk about the great language. So how does Rust solve these things? So it uses a standardized result type, which is always used for error handling. Therefore, there is no question like which magic value means what, like in C. It's always OK variant means operation succeeded, error variant means operation failed. It is impossible to construct a result that either contains both variants, so that it both has success and error, or that it contains neither. Then it's impossible to accidentally access invalid data. So let's say you opened a file, it's impossible to accidentally try to read from the file if the opening failed. Not only is it some magic compiler error, there simply isn't even syntax to express what that would mean. Like that, at best you can pretend that you are trying to correctly handle the errors and cause undefined behavior in the wrong case. You could do that intentionally, but there is no like first-class syntax to trivially access invalid data. So this is like, if you want to do it on purpose, it's super clunky to do it, which is great. There is also standardized error trait. So for like simple things, when you want to maybe format your error somehow, display it to the user, there is a trait that pretty much every library that is high quality implements. And recently it was even added to the core library, which means it doesn't need operating system or an allocator. So if you are doing some embedded development, you can use this trait from the latest Rust version, which is cool. So there will be some tricks for this, but maybe we'll not need to use them. Then we have the question mark operator, which is I think a great balance and best of the both worlds of having exceptions and having annoying ifs. So As opposed to exceptions, you can see where the question mark is. So you have no questions about like which function can throw, because you can see the question mark in the code. And on the other hand, if you just need to do like this super common operation that you just want to return from the function, then it's just one character long. It's not annoying to type, nor is it annoying to read. So it doesn't clutter the code. It's super cool. And in most cases, if the libraries allow it, you can statically inspect the error type. So there is no problem with like accidentally reading any correct type, because you will get some sort of type error if you try to cast the error, or rather, if you match on something invalid, you will get an error, and you won't have some broken code by accident. In most cases, like there are some niche situations where it could happen, but really it's almost non-existent. Then the error types can be enums, which is again really cool, because they are basically lists of possible errors. So you can just check the type that the function returns, and you can see all the possible options. And not only that, but if you want, you can exhaustively match on these. So you can ask the compiler to warn you or error if you forgot to match on something, or handle some case, and so on. So that is really cool and really helpful if you need to make sure that your code is perfect. And the errors are usually stack allocated, but there are good reasons sometimes to actually do heap allocation, and you can if you want, if you need it. So that's the cool thing is that often the error types don't really need to be that large, that expensive to create. So the stack allocation being by default is really nice, but in some rare occasions you can do heap allocation if you really need to. And forgetting to check a value is in some cases completely impossible, as the file example, but even if in cases like if you try to write to a file and you really don't care about the return value, then you still will get a warning if you forget to check the result. So this is also cool. So this is how the result is defined for if there are any new bytes. Basically, it's two variants. It's either OK or error in generic over the types. So you can use any types for the return value and any type for the error value. And only one of these variants is possible at the same time. There is also this question mark operator. So for those who never seen it, the idea is that every time a function can fail, you can write question mark at the end, and what it does is it returns the error that was returned, if there was an error, from this function. And if needed, it will also convert it using the standard conversion trait. So basically, you can, in many cases, you can just question mark your code. Although this specific example is problematic, and I will tell you and show you why. But at least in theory, you can do this. So now, what's so hard about Rust? Well, it's this question. It always pops up, like, what should my error type be? Like, should I do enum? Should I do struct? Should I do something else? And maybe if you are new, you panic seeing this question. But as you get experience, you learn what type to use, and you stop panicking, and so on. And eventually, you will get even more experience, and you find out that panicking was maybe a good idea. So this is kind of controversial, because there is this like movement in the Rust community, and when a new guy comes and they panic. people say don't panic and return an error and so on. But my opinion is not so fast. There are very good cases where when you really should panic. Obviously, the first one is panicking on programmer errors, and by this I mean like some internal invalid state of the function. So if you cannot write your code better, so your function for practical reasons must have some invalid state, at least in theory, then it's not great to return this error if you do encounter it, because that should never happen in the first place. Because if you return it, then the callers need to handle this error, and what they will do with the error? They will probably just panic because they don't know how to handle the error, or they will, if they decide to propagate it up and show it to the user, what will the user do with something internally failed in the code? How will they fix it? There is no way to fix it. It's just a programmer error, and you are just wasting everyone's time if you are returning this error. So for these kind of things, you should panic. But of course, you should try to write your code such as you don't need to do it in the first place. Another case is if the tool is internal to you or to your organization, like you are doing some automation stuff for yourself, like automatically, I don't know, downloading your photos from holiday or whatever. It's just for you, or maybe it's for company, but it's only used by your colleagues who are all programmers or whatever. And basically, it's a very simple tool. Then I say also panic, and or maybe unwrap. You know, like you can use the unwrap method on result, which panics if there is an error variant. So why? Well, simply because that's like the real difference for you is whether the program will print out nice error message or slightly less nice error message. And if you are not panicking, you are basically spending time making your code nicer for very little benefit. So I think it's better to panic in most cases like this, at least at first, unless you hit some good reason to not panic, because like it's kind of a waste of time to make the error messages nicer for yourself if you know the program well. And if you know that there are cases where you can know program well, but the inputs to your programs are so complicated that panicking is not appropriate, which happens to me in practice. But in those cases, okay, don't panic. But there are, you know, these are different cases. I don't think you should just blindly not panic every time. Neither you should blindly panic all the time. And I will mention this project of mine. So there is another different reason, and it's also the reason why I say the previous code was problematic. But take, for instance, this example. Let's say you run this program and it returns file not found. Which file? Oh, that is right, so this directory isn't found, right? Wrong, because command can be also not found. That's one thing. And you just get file not found. Okay, so which? You don't know. Okay, so maybe you will add some context. So you have to then do some error handling, maybe pull in some dependency and write which file it was. And you spend a lot of time just to say which file it was. But if you just write dot unwrap or maybe dot expect with a nicer error message, you will instantly see at least the line number, so you can check the code which operation it was. Or if you wrote the expect message, you can see it from the message, like which, and from there you can very often figure out which file it is. Like if your program takes, let's say, two arguments, one is input file and one is output file, and you see message the output file was not found, then you know which argument it was, of course. It's very simple and quick to check. Of course, it's if you yourself wrote the program, like as I'm saying, internal tool, or your colleagues know well what the program does. If this is something that is intended for some foreign users that maybe don't know exactly how the program works, then this doesn't apply. But if this is something internal now to you, you will actually save time not writing this error handling. And you will also save debugging time. Okay, but let's say we are not in this situation and you still need some error type. So my next answer to this question, like which error type should I use, is that the best error type is no error type. So basically you try to design the program such that there are no error types in the first place. And the way to do that is to use the so-called new types, for instance. So let's take this function that just computes average, so it sums up the input and divides it by the count, and then returns the result. Obviously, if you pass in empty slice, you cannot compute average because, well, there is division by zero of something that even cannot be summed, like what is the sum of empty list? Well, you could argue zero, but I wouldn't say exactly so because maybe it's negative number. So what you could do is basically return error for a swipe that was empty. That's the natural idea, and maybe even define your nice error type and so on. But this is kind of annoying because maybe the core already knows that the slice is not empty for some reason, and the core has to call unwrap on the result. What you can do instead is use so-called new type. This is also kind of the special technique because it uses a bit of unsafe to have a unsigned zero type, which is kind of advanced, but the idea still stays. And the idea is to create a type that cannot ever be that cannot have the value that this function considers invalid. So in this case, the type that you don't allow to construct with an empty slice. And you write a try-from conversion for some other type, let's say. So then you have separated the concern of validation from the computation. So you have your, basically this is your business rule, and this is some input handling. But okay, like what did I get? I still have this result there, you just push the stuff up there. Well, the pushing stuff up is also very useful because if you have like a call stack that is deeper, like then you avoid passing invalid data through deep call stack and then returning an error somewhere deep. And the idea why this is good to avoid is that the closer the error is to the input, the better the error messages can get, the less messy the error handling, and like if you have like function that requires this slice and then then it goes, or rather it is called by another function that just passes the slice through and so on, then you have to deal with error handling all the way. But if you use this special new type, you get rid of all that. You just pass in the already validated type, which is definitely valid. And you don't deal with error handling, and you only deal with error handling on the edges where the users inserted the invalid value possibly and show the error message. But there is a second reason that maybe, why it's jumping so much? So maybe the core already knows that the slide is not empty. For instance, the core has an array. So what you can do is you can, for instance, implement conversions for some other types. You can implement conversions for some other types that you know for sure are valid. There are cases like this where you have restrictions on limits of inputs on lengths, so you can implement it for any. Of course, I put one here as an example, but it would probably use macro and use just bunch of possible values. Unfortunately, currently Rust generics, const generics do not support expressions like implemented for all arrays except for zero length arrays, but one day maybe they will be. I think it's still available on Nightly. I'm not entirely sure. You will probably get some nasty warning that you might encounter very huge problems if you do this, but at least in theory you can try it out. So it might work. And then if your caller didn't get the input from a user but from somewhere else where it got fixed amount of inputs and it's an array, then there is no error handling at all. So this is really cool. To be frank, I even have very similar application. It's not that the input is non-empty, but there is a limit that the size has to be at most 128 items. So what the library does is it implements from all arrays up to 128. It's not that much, and it does it with macro, so it's fine. And then I know statically what the array sizes are, so I don't deal with errors. So this is really cool. And you can do similar things with integers, for instance, like maybe what you need is an integer that is, let's say, up to 50,000. So it doesn't fit into U8. It does fit into U16, but not all values of U16 are valid. So what you do is you implement from U8, because if your application already has 8-bit number, then you know for sure that the conversion will succeed. But if your application has a bigger number, then it has to deal with the possibility that the conversion will not succeed. So this is a really cool idea. And there is another idea, like as I said before, with this like separating like you separate the processing of the user inputs. So let's say you have an application that has an input and an output, like something very simple, some filter. And so what you can do is design your application to have roughly this design where you first parse the input and feed it to like new types that make sure that the invariants are valid. Then you compute your business rules on this, and then you format it. This is super cool, and there is one nice thing that you can probably use the third library for the parse part. So you can implement third for your new types, such that you can deserialize only valid values. So then your parse becomes pretty much trivial. You just derive stuff on structs, which is kind of cool. And it works many times well, but it also breaks down in some cases. And here is one example. This is from my own configure me crate. So what the crate does is it generates the parsing of your program's configuration, which means arguments, files, environment variables. But let's forget about the files and stuff. Let's focus on parameters. Or rather, it doesn't really matter. That's irrelevant, but basically any value. So there are these rules, like an application parameter can be either optional or mandatory, of course. A parameter can also have a default value or not. But it doesn't make sense to make a parameter mandatory and give it a default value. Because like if you like, what's the default value for if you have to specify the parameter anyway? Therefore, we want to rule this out. And the settings for the, or rather the specification for how the parsing should work is written in two toml fields. Because like you could figure out like how do you present this to the programmer who is reading this, like how do you make him to specify whether which strategy should be used. And the most intuitive, easy, and simple way is to have like two possible fields, like one where you can put in default, and the other one where you can say optional equals false, which makes it mandatory. If you want to have optional as a default, you could also have default as mandatory and do it the other way around. And so you have two fields that could be set to conflicting values, and then third will not help you that much. But there is a solution, and it's actually pretty easy, and it also kind of has a relationship with this whole idea, is that you define an enum, let's call it optionality, and there is mandatory, optional, and default value, and what the default value is. So this is your input for business rules, for whatever will compute all this stuff. And then you just use a relatively simple match. It is a little bit more scary because there is one thing that there is the default optional setting. So if you have like 20 parameters that all are mandatory and you don't want to write optional false for everyone, you can just say if I don't specify otherwise it will be mandatory, and if I want to make it optional, I have to specify optional equals true. So you can flip it. So that's why it's a bit more scary. But if you count all possible options, like without this thing, it will be 2 to the power of 2, which is 4. So it's pretty nice. So basically the idea is you first parse the input to be pretty much the same as the intended input the user has. And then you just do some processing. So basically you architecture your program in this way, where you first, there is a weird quirk. I think this is caused by some graphics problem, not by me being stupid, but I'm not sure, don't quote me on that. So parse should point here. So the first stage of the program is parsing, where basically just all the data the user inputted into a struct, which pretty much matches with its layout what the user sets. Then you have validation phase where you validate the fields, and there you construct new types or enums or whatever you need that match whatever the business will need. Then you do your stuff, and then you format it. Of course, if you had it's similar, like the output of your computation is too dissimilar from the output of the program, you would have another layer, but we are talking about error handling, not formatting, so that's where I shut up about this. That's just to point out the obvious. So this is a very interesting way of approaching this. But let's say you still did all this, and you have some sort of like system errors, like found not found. You cannot do this like, is it correct correct type for things like found not found, or for other operating system errors. So you still need some type. So then my question is, if you are asking me which error type I should use, is if you are writing a binary. If this is a binary, and it's supposed, of course, if it's supposed to be shipped to other users, just use anyhow, at first at least. So anyhow is a crate that helps you with reading the errors. So you put this like anyhow result everywhere, and it will have this anyhow error, which is pretty dynamic, and it just carries the data, and it can add an error message. And what is really nice is you can write the context by just, you of course need to import the context trait, and you just call the context method on result, which will transform the error to give it additional information. Or you can even things like with context, where you do costly construction. So for instance, if you want to say which path fail to read, then you need to allocate that path on the heap, unfortunately, but then there is no other option. So at least you make sure that you don't allocate it on the success path, because that would be wasteful. So you can use this method. And this will cover most of the applications, probably, because most of the applications don't need like super weird error handling. Basically, you just want to print the error somehow, maybe do some cleanup, and that's it in most cases. And in those like very specific cases, like I wrote some application that needed to, I'm not entirely sure what it was, but it had to deal with whether the file it created is new or isn't. So it tried to create a new file, and if it failed, that the file exists, it wasn't actually a true error. It needed to be handled differently. I don't remember the exact details, so maybe I'm kind of messing things up, but something like that. Then yes, but you only do it at that place usually, and it's rare that you would need to do it like several calls up the stack. But it could happen, and in those cases you will need to change your error, but probably you only need to change your error for these specific cases. So not for the entire application. So then maybe you can transfer all other errors to anyhow. This works fine for most applications except HTTP servers. Why? Because HTTP servers usually want to return some much nicer like HTTP error codes and so on. And not only that, but there is this funny thing that you probably don't want to report internal server errors to your users, because it may leak some information you don't want, and maybe make you vulnerable to something or confuse the users. Like, again, what is my mom going to do with this internal server error? Like, the page should say, this is the phone number for support, please call this. So for HTTP servers, I figured out that this pattern is really nice, where you have error that has basically, it kind of maps to whatever response do you want to send. So, and if you look at this, you would say like, wouldn't it be easier to just send back the response? And I would say kind of, but then you have to instantiate the same response on every place you want to return it from. So your type gets simpler because you don't have to define it on one hand, but on the other hand, every place where you return it gets more messy. So I don't think it's a big improvement to just use response. Also, I'm not sure how large the response time is, but this can have performance implications. So that's another reason. And also there might be testing implications, like if you want to unit test the function, maybe it's better to check if the returned error type has some specific value when it's an enum and not parse the response or whatever other thing. So I think this is nicer. If this is some like more professional HTTP server, or it doesn't need to be super professional, just like something you are shipping to someone else. And this is how you would basically match the values. So this is actually from a real application. And here is also some very interesting thing that I have redirects here. So it kind of maps to response, but it's not like some error code. It's just that I want to redirect to login if the user is not logged in. So I have pretty simple like match that processes the code and so on. So this is how you can do it. And there is also this interesting idea that you can define this function that I call the log and convert, where this is especially nice for those internal servers. So usually you probably want to log the errors. And what this function does is it returns a function, or rather closure, which takes an error, and when this error is taken, it logs it, and then it calls some sort of conversion on this error. And the conversion is defined by my application. And what I can do then is I will call .mapError and call this function here. And if you ever used mapError, you know that mapError takes a closure, which is kind of interesting because usually you are used to like seeing closure here. And what it does is it just processes the error. And this is, if you think about it, this is very similar to the context method the anyhow has. But there is one simple difference, like why should I use this and not write an extension trait? And I would say it's a trade-off. It's not wrong to write an extension trait for a result. But this has one advantage. If someone new comes to your code base and sees that there is map error, they know exactly what this is supposed to do. Maybe the person will be confused, like, what? Why is there no closure? Because I've never seen this thing. But at least there is this conceptual idea, oh, okay, this is doing something with the error, and maybe it's not interesting for me, so I can ignore it. Or maybe they will figure out it's a closure, and then it's obvious. So it can be a little bit more readable for someone completely new to the code base. It's a little bit annoying to write, of course, because you have two function calls, and maybe it's longer. So I'm not saying it's wrong, it's just a really interesting idea. So this is how you can use it. And basically the idea is that you propagate this low-level error first, or rather like this kind of like business level error through your functions. Then you convert it more to the response kind of error and log it. And then you generate the response from that. Then if it's not an HTTP server, maybe you are asking like, what if my application is kind of similar to compiler? So it takes complicated text input from the user, or programmer, or whoever. It somehow processes and creates an output. And in those cases, in my experience, if like the case is really like you have complicated text input, you really want to try to achieve the same level of error messages as the Rust C has. So it can be like scary, but it's not really that hard. There is a great crate called code span reporting, which will help you with rendering the messages, or rather it will completely do it for you. You just need to feed it correct inputs. So that part is pretty easy. But in those cases, your constructions should be probably something like this. Now, if your language is not based on Tomu, you will probably have a harder time, and you will have to track your spans manually and so on. But Tomu has this cool feature called spend. And what you can do is that you deserialize your type in something that is wrapped in spend, and this type then contains the span where the item is. And what you do then is it's similar to the first idea of like parsing the input that is close to what user entered, but what you need to do is use more like raw types. So in this example, we have non-empty slice, but with third you parse maybe even empty vector. And sorry, not slice, but vec. It's not the same thing, but very similar idea. Like let's say your input must not be empty. And the reason is that the third traits do not allow you to easily pass more error information. So I figure out this is better design where you try to parse the TOML as simple as possible, like with no validation, and then you do the manual validation afterwards, and you convert these types. And this is what I use in 2 of my projects, and it works really well, and solves this problem of third being kind of limited. So you can, for instance, create error like this, where you can have like different kinds, and you store the span inside the error, and you can then use the span to render the grade error messages. So this is used in configure me code generator. So the crate configure me consists of 2 crates. The configure me crate, which is basically just the facade for some other crates. And there is the code generator crate, because you have to use the build script to generate the code, of course. So you include the generator crate from the build script. And this generator crate has this feature. So if you are building your application and you wrote the specification for how your inputs will be, and you made a typo there, then you can try to compile it with the spend feature turned on, in which case it will use the spend the code spend reporting crate and the spend feature of TOML to output messages that are as good as Rust C, pretty much. I think I found a bug there recently. I think it was that one which I sent to you. So I will definitely want to clean it up at some point, where it shows something ridiculous, but pretty much you can get really nice error messages. And there is the Depcrafter, which is a really interesting project where you write kind of like a higher level specification of what your Debian package is about. So like if you ever try to package a Debian package, it's pretty complicated. There is a ton of files which you need to fill correctly, and there are some relationship between some files and so on. So this what this does is takes a higher level representation, which is actually still quite complicated, but not nearly as much. And most importantly, it makes sure that the stuff is synced, like there is like single source of truth and so on. And then basically the design is exactly like I showed before. Like it has the parsing stage where it uses Serda with TOML to pass the data to something that is close to what user inputs. Then there is validation stage, which tries to figure out the spans of errors and such. And then there is a computation stage, which does all this stuff to generate the files. And in case of error, there is in a completely separate file, there is super large like match and stuff that tries to show you really nice errors that like look really great, just like Rusty. Talk about libraries. So if you are writing a library, what your error type should be, well, it's too complicated, so I suggest you just give up. But don't panic. First of all, don't panic in a library unless it's a programmer error or you are in the prototyping stage where you just don't know what your library even will look like. In that case, do it similarly to your application. Like you probably will want to use the library in some application. You are probably not writing library just because you want to write the library. And if that's the case, you just write panics there first. And once you figure out how the structure will be and what the API will look like and so on, then you don't ship the panics, of course, never on crates.io. You can push it on GitHub, but please don't put it on crates.io, it will be just mess. But then, once you are set, I suggest that in early stage of development of the library, you write something like this. And this is from real code. Basically, we have, maybe your enum will be smaller, of course, but in my case, it was like super large enum that there is a bunch of stuff that can fail, possibly. So, but I wasn't sure what information do I want to add into the enum, whether this will stay like this, maybe it will change in the future. I have no clue. It's really, really early stage of library. So what I do is I don't make this enum public, it's just pubcrate. Or maybe I could just, keep it private. Depends on your use case, of course. In my case, I think pubcrate was pretty reasonable. And I hide it inside a wrapper struct, which prevents the users from accessing the enum and relying on its content. So this is great if you want to have somewhat stable-ish crate that you don't break the API too much, but you also want to be able to expand or change the errors and so on. And this is also the kind of stuff that is really not that important for my library. First, I want my library to work properly, which currently, by the way, it's not even fully done yet. So I don't want to waste time with getting perfect errors. If there is a chance that I will have to completely get rid of some errors or maybe completely rewrite them, of course. So I don't want to do that. So this is a great pattern, and this pattern has one disadvantage. Changing this struct to an enum, even if you keep all the traits exactly the same, all methods exactly, everything exactly the same, just changing struct to enum is, if you take it absolutely strictly, it is a breaking change, because there is some completely stupid pattern a user could write that breaks if you change it. And it is basically if you try to match on the struct, if you write something like let struct name and the braces, and you use ... and equals whatever. If you do this and then it changes to enum, it will just break. I think this is too ridiculous, and in my crate I put the warning like, sorry, this is outside of my guarantees. If you are writing code like this, then you will be broken, whatever. I don't care, because I think it's too ridiculous of code. But maybe if you have a different opinion, like, okay, never ever do these things, then maybe don't. And in that case, you will have to just expose the internal field or have some getter or something to keep it. So that's the disadvantage of this. Another disadvantage of this is if you keep it too long and there will be too many production users on this, maybe they will start parsing your error messages to get the insights of this. So just be careful about it. If you incentivize your, and funnily enough, if you do that and then change the display representation, you have broken them, even though it shouldn't be. I mean, changing display representations for some types is actually kind of breaking, because often, like, if you change the representation for integers, let's say, it's kind of really weird if you just started to displaying them in hexadecimal or something. That would probably break things. So that would be reasonable to be breaking. But for error messages, I think error messages should be generally out of scope for this. So if you change an error message, maybe to fix a typo or to clarify it, it shouldn't be a breaking change. But if people start parsing your error messages, that's a problem, and you will force them to parse if you have a production crate that uses this pattern way too long. So once you have in this situation where you already decided what the enum should be, what the variant should be, but maybe you are not entirely sure if maybe in the future you will add more variants, then you probably should do something like this, where your enum is marked non-exhaustive, and you have all possible variants. And then there is one important thing. If you really want to stay forward compatible, then for each variant you should have a special error type, which is also either an enum that is like this, or it should be a struct that wraps some information inside. Some of them may be hidden because you are not sure whether you will keep it or not, and some of them when you are absolutely sure you will keep, you can make it public, either public fields or getters or whatever. So this way you can change the internals, you can change the errors without breaking people, and yet you give them quite a lot of information which they already can use, and they will not parse your error messages or do other crazy stuff. God forbid transmuting the stuff. And then, so this is like a kind of not necessarily early stage. Maybe you will for some reason know for sure that you will never get rid of non-exhaustive. Because maybe you are implementing some protocol that you are not the author of. So someone else implements a protocol, and this person or organization, they decide whether they will add in more stuff to the protocol, and in that case you need more error codes or error messages. So you will never get rid of non-exhaustive in that case. Forgot to say what the non-exhaustive does is it forces people to never exhaustively match on this. So if they want to match on it, they have to have the wildcard case, which matches some unknown variant. And the cool thing is that if you add the variant later, their application will not break, but if they try to build it, they will still get a warning. So it's not like some silent problem, but they can decide that, okay, I don't care now, I will just upgrade the library and I will fix it later. Or they can decide, oh, okay, I'm pretty sure I need to fix it now. So I think it's a good trade-off. But in some cases, you can be sure that there won't be any other error type. And this is a great example. If your function parses hexadecimal inputs that are like strings, no spaces and such, you are sure that the only possible errors are invalid length, because if you have a half byte, like how do you parse it, and invalid character. And there is no other way it could fail. And in that case, there is no non-exhaustive, you have just exhaustive. You still can hide these variants, because maybe today there is just the character that was invalid, maybe tomorrow there will be a position where it failed, and maybe the day after there will be even like multiple characters, who knows. So there are different ways to do this. So this is how your API can end up with eventually at some point. And of course, sometimes the thing is so painfully obvious that you can do this straight away, like in a hex. Like you don't need to wait until whatever to mark it exhaustive, or rather not mark it non-exhaustive. So you can do it straight away. So that's one thing. Then there is speaking about hex errors, there is a whole topic of like parsing errors. Like if you are trying to parse a string, how the error should look like. So similarly to how I described the problem with the IO errors that don't carry the path, I think it's really great if you just try to carry as much contextual information in your error types as possible, because it will make debugging much easier. It will make it much easier for users to understand what the error is about. And this is a pattern I developed. So basically the idea is that you have the input carried in the error type, so you just allocate it, and there are tricks how to what to do if you don't have an allocator. And they do carry some additional information in the struct, and maybe the source error. So this is something we did in a library where we wrapped the parseInt error from the core library, and we added this additional information. There is this super funny comment here, if anyone read it actually, that says that these two variables can be combined into 1 byte, but it's useless because this variable is already larger than 1 byte. So because of alignment, it won't help with any optimization. This comment is really funny because ideally, and the library is like going to change in such a way that this input string may not be here in some cases, and it's in the cases when you don't have any allocator. In that case, you cannot carry the input, unfortunately, so you will at least give some error message, but it will be worse error message. But there is also, well, there is a small solution which I will talk about, but there is no like super universal solution. So, and in that case, this size is 0, and then it would make sense. So let's talk about the size of errors. The thing is that if they are large in layout, what they cause is the entire result gets large, and then if the result is copied from function to function, it will cause a lot of copying overhead and will slow down the function. And this is also the thing I mentioned, that sometimes it makes sense to actually heap allocate the error because it's so huge that if you were copying it around, it would actually be slower than the heap allocation. So I cannot tell you when to do this, but the general like rule of thumb is if the discrepancy between the variants is very large, then you probably do want to do that. So if you are returning, let's say, 1 byte from a success case, but your error message is error type would be a kilobyte, then probably you want to do that. And maybe also like you know, like as always, measure the performance, like what is it in real life, because maybe the function gets inline and compiler sees that the result shouldn't be there in the first place and eliminates it and so on. So you should definitely profile before you do stuff like that, but like in general, the thing is if there is huge difference between the sizes, then you should do it. So maybe even we will refactor it. We will have to merge this field. And as you can see, the great stuff is that these fields are private, so we can do that without breaking anyone, which is cool. This is something I just talked about. I just forgot to switch the slide. Okay, but what if your library wants to support stuff with our operating system? So there is this trait, the error trait, which is the standard trait, which you would implement like this. And this is for old versions. So if you are using the latest Rust version that just came out recently, you completely don't need this section. But if you also want to force this version on everyone who uses your code, of course, you can just sleep now and wake up later. But if you do want to support all the compilers, maybe the general like team is supporting Debian stable, which has 1.63 in it. Then you need to still do the trick that we used to do in the old days. That is, you do conditional compilation and you implement the error. There is one problem though, that there is a rule for the error trait that either your display implementation should only display your own error and not the source, and then you return some in the source function, or you return none and your display shows everything. And the reason is that some code wants to format the errors. For instance, instead of like the common like colon space, they want to put line breaks. So you see sources one under the other. You can see that in cargo, when you get an error from cargo, you will see like caused by something, like each on a new line. So if you did something different than what I described, you would either get same message twice, which looks silly, or you could even not have a message. But the problem is if you have conditional compilation, then it gets even messier, because if you do it like what you would with STD and you just slap this here and you are done, then without STD you are losing the information from the message that could have been there. So you probably want to write it in the display implementation, but on the other hand, if you just change the code to write it, then the STD implementation is wrong. So you probably want to like switch it. And of course, we are using Rust, so we have also macros. So this is an example of macro you could write to do that. So this is also actually used in production. And basically then instead of write, you use the write error macro. It works almost exactly the same as the proper write macro. And the only difference is that it ends with semicolon and it's followed by the source. And there is some trick to prevent clippy warnings and stuff, but the idea is that you put the source there, and then if there is STD turned on, it will not format the source. If the STD is off, it will add colon, space, and the formatting of the source. And this way you will have the error message there all the time, except the source cannot format it nicely, like one line under line or something. It will be forced to do this, and with STD you will work with this. Of course, today you should add here some condition that Rust version is lower than something and so on. So you probably can figure it out. It's not that hard. So this is something that we also didn't implement yet because the Rust version came up only recently. And this is how it looks like. So we have this error kind, and in the display we are just matching. And for cases where we have source, we use write error, and then use the error source. And for the case where we don't have any source, we just use write. Okay, but what if you are doing library that also wants to work without allocator? So I have already mentioned the string, the input, carrying input. And here's another idea. You can have something which I call the input string. By the way, I'm thinking of putting this into a separate crate. I wanted to make this a crate before the talk so I could show it off, but somehow I didn't manage to do it in time, but it shouldn't be too hard. Maybe if I do it, I will send a link to someone here and they can put it somewhere for you to see. So the idea here is that you have a struct that basically wraps some storage, and storage is conditionally either nothing, like empty type, or it's string. And if you have allocator, it's string. If you do not have allocator, it's nothing. You implement everything that needs to be implemented, and you also implement from conversions. Yeah, I didn't show them here. Basically, you implement from str and from string on. So you implement from str in every case, and if you do not have allocated, it just does nothing, like ignores the string input and does nothing. And if you have an allocator, you you allocate the string, and you can also implement from string itself if you do have allocator. So that's a way to do it, and then you have some type that maybe carries a string, and then you can have some methods on the string. So in this case, there is a method on the string. So basically, this self is a parse error that has similar structure as I showed you with the parse number error, and that is you have an input string and some other data. And if this input string was there, then this method on it will display cannot parse, and there is the name of thing that it parse. It's not a name of a type. Like, you shouldn't put types in the error messages because users don't know what the type is. But if you have like something like, I don't know, like cannot parse salary, then the user understands, okay, this is some sort of salary in some input. It cannot parse it, and there is maybe the this is combined with write error as I mentioned before. So if you have std enabled, you also automatically have allocator. So it just displays this part, and then the source takes care of the rest. And if you do not have allocator, sorry, I meant to say, if you do have std, it will say cannot parse and your input string as salary, then let's say. And if you do not have, then it will not save the input string. You can make sure that basically both error messages make sense in both cases. It's not that hard. So this is like this output that is an example here is for the case where you do have an allocator, and if you do not, you just basically remove this part and s, and it will also still make sense. And there is also I don't have this example here, but another interesting case is if you are basically want parsing an enum variant, like there is like, let's say 5 possible strings that the user can, then you can have like this is not valid something, like let's say foo is not valid strategy, and you can make sure that the display makes sense in both cases. So this is a trick how to support both of them. And there is another interesting idea that I haven't implemented yet, or rather we where I contribute didn't, and that is limiting the string length. So the idea is that first, this is kind of still annoying because without the allocator you lose the information, which could be useful. Second is that if you have entered kilobyte long string and there is one typo in it, well, maybe you didn't do it manually, but for some kind of longish things, sometimes people do input them manually, and if there is a typo in the middle, then you are seeing everything. So the idea was that, and the example would be like something like hash, like, can anyone see where the typo is in the hash? Do you see it?
It's a 0 and an O.
Yes, okay, it's pretty visible, but still, like, I used a stupid, no, I used stupid example because I put the O next to 0. Maybe if I used it here, it would be less obvious. But still it's annoying. So there was an idea that you could store just the part of the string where it's relevant. You store a little bit before, a little bit after, and then you display like dot 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 part of the string dot dot dot. So that's pretty cool. You should probably store whether there was a beginning or not, because if this happens to be beginning, then you don't want the dot 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 here, and so on the end. So you probably have 2 more bits there. You just store this. And for many types, this can be even done in core, so no allocator. Of course, your type gets bigger, so there is also still the trade-off that I mentioned, that probably you don't want to make the string too big. But at least you can do it. Theoretically, you could make it configurable with feature flags, of course, and such. And it's less annoying. So we didn't implement this yet. We plan to do this. I think it's a cool idea. And last but not least, let's talk about the idea of handling multiple errors. So just like Rust C, if you try to compile your program and it has multiple problems there, you will get multiple messages. You maybe want to do the same for the user. Maybe if you use web forms or if you are writing compiler-like application. And obviously you just use vec errors, so you put them in vec. But sadly, you don't have the question mark operator, so everything is quite manual today. I have to push the errors. But there is one thing that maybe I should point out. That maybe what you want to do sometimes for some errors is to group the same kinds of errors together, because it looks better if you have like one error saying that this problem is repeated multiple times over your code. And one example is if you have missing several fields. So in this configuration I mentioned, like let's say there are like two mandatory fields, foo and bar. You want to say like there are fields foo and bar missing, not there is field foo missing and then separate message there is bar missing. You know, it's better to group them. In this case, here is a cool macro that I wrote for this thing. So one thing that I also did with the struct server thing is, instead of having like all fields mandatory, I just set every field to an option. I'm then post-processing it. Another thing. Well, in the end, I even end up writing my own macro that implements this row a little bit differently. And we can actually, no, you cannot see it here, sadly. I have plans for improving this. But the idea is that there is a match whether every of the required fields is set. And if it is, I will share the slide, so don't worry about it too much. But the idea is, if every field is set, then we just return, or rather. So what this macro does is actually sets the variables. So as if you wrote let whatever equals whatever let equals, and so on. And if there are some missing fields, it will just populate the vec with all the missing fields and return one error that contains all of them, and it returns. So this is kind of like, you can say it kind of resembles the question mark operator in the way that it's returning and doing some error handling and processing. So it's kind of a replacement for this specific case. There are other cases. This is one thing you can do. You could also do something like, this is something I wanted to do but didn't have time yet, is like you pass here even the vector of other errors that happened unrelated to this, and then so the idea is that you could pass some argument that contains the vec of errors that are not related to missing field. There are other errors, maybe when an optional field that wasn't mandatory failed to parse, and then you would, instead of returning this error here, you would push it to the vector and return the whole vector. So that's one thing you can do. And what is this? Yeah, so here's another idea how you could do it in a library if you wanted to support multiple errors from a library, but also not bother people who don't want to handle multiple errors with it. So the idea is you hide the error type, and you have public, like, I'm not sure if error kind is great name for this, but I didn't come up with anything else. So feel free to come up with a better name. But the idea is you have an enum of all possible errors that can happen. And you have function that returns the first one always. So users that don't care about multiple errors just call first and they are done. Users that want to handle all of them call the all method, which returns an iterator. And this is implemented differently. If there are multiple errors, it will chain the first one with the remaining ones. And if there are no multiple errors, if there is just single one, it just returns this first one as the only one. So this way, the API is same for whether you are capturing all errors or not. And you can have a feature which toggles the behavior. And the idea why not to put everything in the vec is that first it statically proves that the first error is always there, so there are no unwraps or whatever. Second, it could be more performant if you happen to have one error. It's probably not that important, but it might be a nice feature. This is obvious disadvantages if this thing is too large, then your struct suddenly became much larger. So maybe a different way to do that is to put the first error into the vec. In the other case, also the disadvantage here is you have to use the chain, which has some overhead. So there are trade-offs. This is one way to do it. The other way is to just use vec all the time, or maybe you could also write non-empty vec, of course, here, because it makes sense. And non-empty vec probably should have also the first method, which returns the first element, possibly without checks, hoping there is no undefined behavior. So that's another idea I had. But this is for libraries mainly. And this is something I wanted to write in production code. I was kind of hoping also that I will manage it before this talk, but I didn't yet. So because there were some unrelated problems in the library that needed to be fixed first, and some other stuff. So that is another idea. And another idea is if you as I mentioned, if you have like this track with several fields that some of them may be optional, here's a little function that you could use. And what this does is it pushes, if your optional field is invalid, it pushes the validation error into the error vec and then sets it to none as if you didn't specify it. But there is one thing that at the end, you must not forget to check the errors, whether they are empty. So that's one thing. And this actually gave me one idea that I wanted to propose to the Rust community, but didn't have time yet for it because I got this idea like, I don't know, 3 days ago or something. And the idea is that maybe we should be able to put must use attribute on mutable references parameters. Because so the idea is, if you have, let's say, I'm not sure if I didn't put it into the slides. I had this idea to put it into the slides, but this is the last slide. The idea is if you make a mutable variable, let's say integer, you first assign some number, and then you have statement like plus equals 1, let's say, and then you do nothing more with the variable. The Rust compiler sees you have written to the variable and it never read from it, so the write is useless, and you probably have a bug in the application where you could just remove the statement. And you will get a warning, but if you do the write not directly but via some function that does the write, and the function knows it's pure function, it has no side effects. Like for instance, errors.push. It does have side effect that it allocates maybe, but that's kind of like boring, useless side effect that isn't really relevant most of the time. So if you write like create a mutable variable with empty vector. In the second statement, you push an item into the vector and then forget to read it. There is no warning. And I had this idea that maybe if we had must use on the variable, then if you call a function with that variable, and of course you shouldn't do it by move. It should be by either mutable reference or a shared reference that may contain internal mutability. So if you use a shared reference to integer, it doesn't make sense because there is no change. But if it's a mutable reference or if it's shared reference to cell or something, then it should be allowed. And what it should do is that the compiler should say that warning, this function writes into this variable and you haven't used the value that you've written. And if this existed, it would probably help with discovering error bugs, but it would also help here because we would put must, let's say it would be must use. I think that one makes the most sense because basically, if you think about it, this is effectively a return value of the function. You are just putting it there for the reason that doing anything else would be less efficient because you need to mutate the existing vec to push the new items there because recreating the vec every time is inefficient. So basically it is as if it was a return value. So must use makes the most sense in my opinion. So you put must use attribute here, and if you forgot to check the length, then you would get a warning. So that was my idea that this would make things much easier and less error prone, but something maybe in Rust 100 or something. So we will see. So that's just one final idea. And that's everything that came to my mind about error handling when I was preparing here. So I think it's pretty large topic, and as we talked, there is more stuff to cover possibly. I'm pretty sure I forgot some things that even I encountered, but I forgot about them. So I hope this gives you some good overview of some basic stuff regarding error handling. Thank you for your attention. That's all.
Thank you.